Okay, today we're going to be learning about something called VSEPR theory. Okay, VSEPR theory ties into the same kind of stuff that we've been doing. We have been learning about valence electrons in atoms and how they're involved in different kinds of chemical bonds. We did some stuff with dot diagrams to show how electrons either get stolen from one atom to another in an ionic bond, or they get shared in pairs with covalent bond. What we're going to be looking at with VSEPR is going to be chiefly covalent stuff. Okay, you can use it a little bit to talk about ionic, but it's mostly chiefly covalent. So VSEPR theory is all about predicting molecule shapes. And VSEPR is an acronym, and you don't really have to know this so much, but just so you know where it comes from. VSEPR stands for valence shell electron pair repulsion. Because the thing you know about electrons, they're negatively charged, and if you've got electrons brought close to electrons, they don't like that. They repel each other because they have the same charge. And so if you have, as you've seen before, pairs of electrons, say located around the outside of an atom, what they're going to do is they are going to orient themselves in such a way where they can be as far away from other pairs of electrons as possible. Okay? Does that make sense so far? And so knowing that, we can use that to make predictions about what kind of shape a molecule is going to take. And so the chart that I've handed you is something you're either going to hear it referred to as a VSEPR chart or an axe chart. Let's talk about what the axe method is for predicting electron pairs. The A in axe stands for the central atom. The X in axe stands for, I don't really know why it's an X. The X stands for a externally located atom, maybe. Or you can call it a branch. And then the E has to do with electrons, okay? It's what's called a lone pair of electrons on that central atom. And these would be electrons that are unshared, meaning they're not involved in any kind of covalent bond. I'm going to look at several examples so you kind of see what it is we're talking about. So here again is a copy of the thing you're holding in your hand. And the way that you use it is you have to figure out something called steric number, okay? Steric number is the total number of branches and lone pairs on the central atom. And so just for example, what you see here in this top row, there are 2 branches. Remember, branches are represented as X. There's 2 branches coming off the central atom, so this has a steric number of 2. In the second row right here, this central atom has 3 branches coming off of it. And this one right here has 2 branches, but it's also got this E. This E, remember, stands for an unshared pair of electrons. And then down here at the bottom, the steric number is 4, meaning that there's 4 total things, either 4 branches, 3 branches in an unshared pair, or 2 branches and 2 unshared pairs. If you take a look up here, this tells you how many lone pairs or how many E's there are. So if you see here in this first column, none of the central A atoms have any E's coming out of them. None of them have any unshared pairs. Either, in these cases, all of their pairs of electrons are being shared with other branches. In the middle column right here, we've got 1 unshared pair. And then in this one here, we've got 2 unshared pairs. And then down here at the bottom, these are the actual names of the shapes. And so you've got names like linear, or trigonal planar, or tetrahedral, or just bent. Now, it does get a lot more complex than this, but we're not going to make it any more complex than what you're saying right now. Okay. Looking at some of these names, what does linear mean?
Straight across.
Right, straight across, just in a line, right? What about, what do you see in the name planar? A plane, right? Which is just, a flat, region of space that has several points that are all within that one plane. Okay, and then of course things like pyramid, you know what a pyramid is, right? What about tetrahedral? Any ideas what that is? Anybody know what the prefix tetra means? Anybody ever play the game Tetris? Okay, tell me about Tetris. What do you do in Tetris?
You line up the blocks and get higher.
You line up blocks? Well, I think you want to not make it higher, right?
Oh.
Because see how you lose. You line them up to make lines, and those lines disappear. Why do you think they call it Tetris? Let me give you a clue here. Okay, some of the Tetris blocks might look something like this, right? Or something like that, or something like this. What do you notice all those have in common? They all have 4 squares. Tetra means 4. So if I've got a tetrahedron, that means I've got a shape that has 4 sides. A 3D shape with 4 sides. Tri means 3, tetra means 4. So I told you we would look at some examples, and I'm going to show you some examples here. So the way that you work these is you start off by making a dot diagram, okay, showing your shared pairs of electrons. And so it's going to be necessary for you to kind of dust off brain cells from a few days back when we were doing some of these. I'll do a couple of them here for you. So let's say oxygen, O2. Okay, looking at my periodic table, I know oxygen has 6 valence electrons. Okay, so I'll just kind of do this in my head here. Okay, it's got 2 in pairs and then 2 singles, so it needs, if it has 6, it needs how many more to be stable? 2. 2. So it's going to end up sharing 2 pairs with another oxygen, or something kind of like this, where I've got oxygen, 2 pairs of oxygen, it's got dot, 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 dot. Okay. Now, the good news is, and this is something you should definitely write down, if you have an atom that has, or I'm sorry, if you have a molecule that has only 2 atoms, that's like saying, hey, I've got a shape that contains only 2 points. What shape is that going to be? It's a line, right? The only shape that it can be if you only have 2 atoms is a line. That's not on this chart because that is common sense. If I was to draw what this kind of looks like, I would have my atom of oxygen. I'm going to show that it's got two bonds coming out here. Now on the other side, on the outside that you can't see, we've got these electron pairs. Okay? Now H2O, same kind of thing. I know that oxygen's got 6. I know that hydrogen, every hydrogen atom has just a single electron, right? Every hydrogen needs to get 1 more to be stable. The oxygen still needs to get 2 more to be stable. And so it ends up forming, oxygen's got its lone pairs, it's sharing a pair with a hydrogen, sharing another pair with hydrogen. Now we've got more than 2 atoms, and so we can make a prediction about what kind of shape this thing's going to be. So we're going to use our axe method on this. Okay? A is to identify the central atom. Okay? What's my central atom in this molecule? The oxygen. Very good. It's the one that's kind of stuck in the middle. So this dude right here. Now, how many branches, how many other atoms do I have coming off of this? 2. Okay, so in this case, x is going to equal 2. So my x's are going to be this guy here and this guy here. Now, for my E is unshared pairs of electrons that are coming off of this oxygen. Does this oxygen have any electrons that are not being shared with other atoms, any lone pairs? Yeah. Okay, right. So here's a lone pair of electrons. Here's a lone pair of electrons. I'm going to end up with 2 lone pairs of electrons. Now, if I take my x's plus my e's to get my steric number, what do they equal? 2 plus 2 equals 4, okay? So steric number is 4. So I'm going to come back over to my chart for just a minute. So steric number is 4. That puts me somewhere in this row here. Now, how many lone pairs did I say I had? My letter E? 2. Okay? So for 2 lone pairs, that tells me I'm going to come down here. For 4 in my steric number, it tells me I'm going to be on this row. And so it's predicting that the shape for this particular molecule is what? It's bent. Okay? So when I write a prediction, I'm going to predict that the shape of this guy is going to be bent. Now let me actually build it, and let's see how close to correct we are here. Now, what is actually bending these 2 molecules here down? what would be pushing them away?
Like the electrons like that are on the
Other ones that
outside.
are there.
The other electrons that are up here. Remember the whole name of this thing is valence shell electron pair repulsion, right? Repulsion means to repel, it means to push away. And so what's happening in this molecule, if I hold it kind of like this, is that these two pairs of electrons up here at the top are pushing these other two branches down and away. So there's one actually up here, and there's one actually up here. And this way those sets of electrons are as far apart from each other as they can possibly be around the outside of this ball. Okay? And so that results in a bent molecule of water. So if I was to draw this, start off with my oxygen. I don't have any yellow markers, and so I'm going to have polyethylene hydrogen, polyethylene hydrogen. I can't draw my electrons because my electron is invisible. So here I've got carbon dioxide, CO2. All right. So let's just in my head kind of think about what those different atoms look like. Okay, so carbon, we remember, it's got 4 electrons, pair, pair, single, single. But do you also remember the thing I said that carbon can do that other atoms can't?
It can move like one of its electrons from the pair to a single.
Exactly right. And so what it can actually end up doing is it can end up making a dot pattern kind of like this. And so I'll keep that in mind. Oxygen, we remember from the last page. We've got pair, pair, single, single. So this carbon is going to need 4 more electrons. This oxygen is going to need 2 more electrons. So how can I arrange these in such a way to where everybody gets a full set of 8? Okay, just to draw my dot diagram. Who's going to have to get stuck on to who? Eddie, talk a little louder. With a very quiet finger. Okay, so an oxygen is going to go to the carbon. I've got 2 of them. So if I start off with my carbon, put an oxygen here, he's got his unshared pairs here, but he's going to have these 2 he's going to share with the carbon. So he's going to make 2 bonds to carbon. Carbon's going to take 2 of his electrons here and bond them to the oxygen. What about the other oxygen?
Gonna go to the other two.
Going to go to the other 2. Okay, so he'll be over here. So he'll share a couple pairs of electrons with him. He'll still have his unshared pairs on the outside there. Now, remember, each one of these represents a pair of electrons. So how many total electrons are around the oxygen on the left? I've got 1, 2, 3, 4, 5, 6, 7, 8. So he's happy. This one over here, same thing. 1, 2, 3, 4, 5, 6, 7, 8. He's happy. Carbon in the middle, 2, 4, 6, 8. He's happy. Everybody's happy. So now we need to predict what kind of shape this is going to take. So using our axe method, what's my central atom here? Carbon. Okay. Okay. How many branches does he have coming off?
4, 2, 2.
He's only got 2 atoms that are coming off of him, right? So X is going to equal 2. There's 1. There's 1. Are there any unshared pairs of electrons coming off of this middle carbon atom? You say no? No. And I agree. He's sharing all of his atoms, so E here is going to equal 0. So looking at our axe diagram, our steric number is going to be X plus E. So our steric number equals 2, right? So looking on our chart, steric number 2, that's up the top right there. What is it predicting for our shape? Linear. Okay? So I'm going to have a black carbon here in the middle. Two red oxygens on the outside like this. And then showing that I've got two kind of bendy sets of bonds going to it. SiH4, silicon tetrahydride. You know what that means now, right? Because tetra means what? 4. Very good. Okay? So it's going to be a silicon with 4 hydrogen atoms. You can figure out dot diagram wise what that's going to look like. How many valence electrons does silicon have? You're like, uh-oh. Well, look at where it is in the table and who's right over it?
Carbon.
Carbon. And how many does carbon have?
4.
4. Therefore, silicon has to have
4.
Perfect. And guess what? Silicon does the same thing carbon does. Silicon can either have a pair and 2 singles, or it can have 4 singles. So you tell me, if I'm going to have 4 hydrogens and a silicon, who is going to be my central atom? Silicon, right? So if I've got a silicon in the middle here, it's sharing a pair of electrons with hydrogen, and hydrogen, and hydrogen, and hydrogen, then everybody's happy. Hydrogen each gets a pair. Silicon has 2, 4, 6, 8, so it's happy. Now let's go to our VSEPR and let's try and predict what this is going to look like. Okay? Again, using the AXE method, AXE. Okay? Central atom is who? You just said it's silicon, right? How many branches? 4 branches. Okay? 1, 2, 3, 4. So X is going to equal to 4. Does silicon have any unshared electron pairs? No, it does not. So my E is going to equal 0. My steric number is going to be 4 plus 0, so it's going to equal 4. So steric number is 4, electron pairs is 0. Let's look back at our chart. So here's my steric number. 0 lone pairs means it's going to be in this column right here. So we're talking about this. What's that shape? Tetrahedral. So let's see what one of these dudes looks like. Tetrahedral means it's going to have 4 sides to it. Now I'm going to come back to this drawing here in just a minute. We're going to talk about why these lines look like how they look. Okay. So here's how I do that. All this over here. Okay. I'm going to have my central atom, my silicon. Now I'm going to turn it in such a way to where this guy's coming off here, this guy's coming off here. Now this one that's going away from us, I'm going to show that it's going away from us by kind of using a little fading line looking thing like that. The one that's coming toward us, I'm going to show that it's getting bigger by using a little spreading triangle thing that looks like that. Now, kind of use your imagination a little bit. Do you see it?
Yeah.
Okay. That's what those mean. Okay. That's going to be a handy thing for me to jot down. So if you've got something that looks like this, it means it's getting closer. It's pointed toward you. And if I've got something that looks like this, it means, actually that's not good. Let me spread this out just a little bit more. This means that it is getting farther. So now I've got CH2O and I've got SbCl3. Which one would you like to tackle first?
CH2O.
CH2O. Okay, so I've got a carbon and I have 4 atoms on, or 4 electrons on it. I've got 2 hydrogens that each have 1, and I've got an oxygen that's got 6. Okay, so this one right here needs 4. Every hydrogen needs 1, and this oxygen needs 2. So how the heck do I build these in such a way where everybody gets what they need? Who do I make my central atom? I can try carbon. Okay, so let's say that I've got carbon right here. Okay, where do I stick my oxygen? Where do I stick my hydrogens? Every hydrogen can only share 1 bond, right? And carbon's got 4. So I might start by putting a hydrogen on this side and a hydrogen on this side, which still leaves 2 more electrons for carbon to share. So who can I share it with? We can share them both with oxygen, right? Something kind of like that. So hydrogens are happy, carbon's happy, he's got 8. Oxygen's happy, he's got 8. Let's use our axe charts to predict what kind of shape this is going to be. Central atom A, going to be this dude right here. Okay, where are my X's at? How many branches? 3. Okay, so he's a branch, he's a branch, he's a branch. Does carbon have any unshared pairs of electrons? No. Now, are there unshared pairs of electrons in this molecule? Yeah, coming off the oxygen, but the oxygen's not in the center. We're only worried about the ones coming off the center. So we can say that our E number is 0. Now 3 plus 0 equals what? Okay, so our steric number is 3. When we go to take a look at our chart, and it goes back over there real quick. Steric number is 3. I've got 0 lone pairs. So according to my chart right here, with 0 lone pairs and with steric number of 3, what's my shape going to be? They're saying it's going to be trigonal plane. Okay? That means I'm going to have an atom that's got 3 atoms coming off of it, and it's going to make kind of a triangle shape. So